Good morning, students. Good morning, students. In the last class, we have discussed about chemical properties of amine group containing amino acids and amine group containing reactions and acid group containing reactions are there. In that, we will having amine and acid group both are present. What type of reactions are takes place, we will discuss about that. And this amine group, what type of amine here? Primary amine is there. So, due to the primary amine, it will be having isocyanate test is also there. So, the phenyl isocyanate test in the earlier we are discussed in that chemistry. Here alkyl group CH if NH2, C double bond oxygen OH group is there. Here what type of amine? This belongs to primary amine. Primary amine identification test, isocyanate test. So, pungent smell it will be takes place. This will be reacts with chloroform and alcoholic KOH. Here the primary amines reacts with chloroform and alcoholic KOH to form isocyanates. Here alkyl group CH, C double bond oxygen OH. Here this one is isocyanate will be formed. So, this isocyanate will having the what type of smell it will be takes place means pungent smell it will be takes place. And another one is N-alkylation and N-amylation we are discussed in the last class. Sanger's reagent is also discussed in the last class. Next one, reaction with alcohols. Reaction with alcohols means here amino acid R CH NH2 C double bond oxygen OH. This acid group reacts with alcohols ROH. This OH group and H it's eliminated as water molecule H2O minus H2O on heating. It forms RCH NH2 C double bond oxygen OR. So, this is called ester group it will be formed. Means in the presence of acidic medium, acids reacts with alcohols to form esters. So, this reaction is also what about the formation of ester, and it will be reacts with lithium aluminum hydride undergo the reduction. Lithium aluminum hydride is mild reducing agent. Alkyl group CH NH2 and C double bond OH reacts with lithium aluminum hydride LiAlH4 is a reducing agent. This reduction means what happened? One conversion we are discussed in the earlier. When alcohols undergo the oxidation, OH that is called alcohol. Alcohols undergo the oxidation, it's converting as aldehydes. That aldehydes undergo the oxidation, it's converting as acids. This is the conversion mode. And if this one is oxidation synthesis, if we go for acid undergo the reduction converting as aldehyde, undergo the reduction aldehyde, aldehydes undergo the reduction, aldehyde undergo the reduction, it's converting as alcohols. This one is conversion pattern. Here acid group is there, here alkyl group CH NH2. Now this one is CH2OH. Acids are converted to alcohols. So here oxidation process, alcohols are converted to, here acid group is there, that acid group undergo the reduction, it converting as alcohol. These are the reaction belongs to amine group and acid groups. Now both the acid and amine groups are reacts with each other. What happens? In that best example is amine group and acid group reaction. The best example is complex formation, formation of complexes, formation of complex. Complex means here coordinate covalent bond will be formed. In this coordinate covalent bond, one is ligand, another one is metal ion. The metal ion will having the deficiency of electrons are present. Excess amount of group will donate the electrons to metal ion to form one bond will be formed. That bond is coordinate covalent bond. That is also called as, here this ligand group is called donor and this metal ion is also called acceptor. The bond is donor to acceptor bond, it will be takes place, that is called coordinate covalent bond. Now if we see that here, if we take any amino acid, now I am taking here glycine. What is the formula of glycine? NH2 CH2 C double bond OH. This one is glycine. I am taking 2 moles of glycine. It reacts with one metal ion Cu plus 2 cuprous ions. Nitrogen having lone pair of electrons are there. In that acid O and H, O minus and H plus it will be there. Here amine group and acid groups is present. In that amine group and acid group, which one is what about the more stabilized compound means, here nitrogen is also having donor sites are there, oxygen is also having donor sites are there. So acid and acid anion, in the earlier class we have discussed about that, acid and acid anion, which one is more stable means acid anion is more stable. Now here this one is copper having the plus 2 charge is there, we are taking 2 moles. This one is NH2, this nitrogen electrons are donated, CH2. Now here C double bond oxygen and here C double bond oxygen is there and here oxygen. This oxygen having what type of charge? Minus. That minus means X amount of electrons are donated. This nitrogen electrons are donated, oxygen having X amount of electrons is also donated here. This is one glycine unit. Another one is here cis and trans is also formed. If you write this here oxygen, now here C double bond oxygen CH2 and here NH2, here NH2, this nitrogen electrons are donated. Here it will be formed as in a complex nature. DMG, dimethyl glyoxime, it will be takes place. Here the copper material, the copper will have the metal ion, nitrogen having lone pair of electrons, oxygen is also having X amount of electrons are donated. These 2 nitrogens are opposite to each other, these 2 oxygens are opposite to each other. So this complex is called trans complex. This complex is trans complex. If these groups are arranged in the same side, that complex is also known as cis complex. Either it will be existing trans or cis complex, it will be existed. For example, if it will be formed cis method, CH2 C double bond oxygen carbon, here oxygen, C double bond oxygen, here CH2 and here NH2. This one is copper, this oxygen electrons are donated, nitrogen electrons are donated. Again here oxygen, C double bond oxygen, here NH2, then CH2. Here it will be formed complex. If you observe here, these 2 nitrogens are same side, these 2 oxygens are same side. This complex is called as cis complex, this complex is called trans complex. So amino acid, not only glycine here, not only glycine, you can take any amino acid. That amino acid, nitrogen having X amount of electrons are there, nitrogen having X amount of electrons, in the acid oxygen having X minus charge is there. These oxygen electrons and these nitrogen electrons are donated to central atom of copper, and it will form what about the donor to acceptor bond is takes place. The donor to acceptor bond is called as coordinate covalent bond. In the complex, what type of bonds are takes place means coordinate covalent bonds are takes place. So, this is will having the cis complex is formed as well as trans complex is also formed. So, not only here glycine, if you change the alkyl group, we are getting different type of amino acids. Note down this. And if we change this alkyl group here, for example, CHR, if you are changing this alkyl group, you are getting different type of amino acid. Here CHR, changing this alkyl group, we are getting different type of amino acids. Here alkyl group is present, and in the CH2, here CH and R, alkyl group, and also CH2, CH and R. We are changing this alkyl group, we are getting different amino acid, and also here different type of metals also we can utilize. So, by amino acids, based on this configuration, what we are identify means, in the amino acid, amine group is reacted, acid group is reacted, both are reacted to form the complex nature. If we are changing this alkyl group, we are getting different type of amino acids. We are in the R position, in the earlier we are substituted hydrogen, that is glycine. In the R position, if you are substituted CH3, alanine, valine, leucine, isoleucine, lysine, tryptophan, like that several amino acids will be formed. So, this is the formation of complex example. Next one, heating of amino acids. Next one is heating of amino acids. Amino acids are heating to form different type of compounds as a cyclic compounds. For example, if you see that C double bond oxygen OH, here CH2, if you take NH2, this is glycine, this one is glycine NH2, CH to NH2, C double bond OH, plus here NH2, CH2, carbon double bond oxygen OH, this is acid. Here this OH group and H, it's eliminate as water, On heating, elimination of 2 moles of H2O, and to form CH2, C double bond oxygen, here NH, C double bond oxygen, CH2. This is cyclic compound is formed. In this cyclic compound, we will having peptide bond is also there. This compound name is diketopiperazine. Diketopiperazine is the common name. It is a cyclic compound is formed. In the place of CH2 position, if you are changing alkyl group, here hydrogen position, if you are adding an alkyl group, you are getting different type of amino acids, R, and here also R. Here CH alkyl group, and here CH alkyl. Now we will getting the different type of amino acids on heating. Note down. These reactions are belongs to heating reactions. Note down this. And if you are changing this alkyl group, we are getting different amino acids. If you are changing this alkyl groups, we are getting different amino acids. Next one, alpha beta unsaturated acids. Alpha beta unsaturated acids. Alpha beta unsaturated acids. In this condition, alpha carbon and beta unsaturation. Unsaturation means either double bonds or triple bond it will be takes place. It's called as unsaturation. For example, if you see NH2, CH2, CH2, C double bond oxygen OH. This one is amino acid, this is beta amino acid. How it's treated as beta? This is functional group. Functional group adjacent carbon is alpha, alpha adjacent is beta. This one is alpha carbon and this one is beta position. The beta carbon amine group is present here. This hydrogen we are substituted here, CH2. Carbon and oxygen here, bonded electrons are attracted. This one is sp2 carbon, these electrons are attracted here. And here nitrogen group is there, these bond electrons attract towards this side. This carbon gets positive charge. To decreasing the positive charge, this alpha carbon hydrogen is donated. To satisfy the carbon valency, this NH3 group is eliminated. Already 2 hydrogens, 3, 4 bonds are there. When these 2 electrons are delocalized, 2, 3, 4 and coming electrons are 5. So, due to that reason, this amine group is eliminated as NH2 minus. These 2 electrons are attracted as NH2 minus and this one is H plus. H plus and NH2 minus eliminated as NH3. Now, the product is CH2 double bond, CH, C double bond oxygen OH. This is alpha beta unsaturated carboxylic acid, acrylic, acridine or acrylic acid it will be takes place. The product is acrylic acid is takes place. And is also preparation of gamma lactam preparation. Here gamma lactam preparation condition, C double bond oxygen, here CH2, 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 here NH2, this one is OH, alpha, beta, gamma. Functional group adjacent carbon is alpha, then adjacent is beta and gamma. In these conditions, CH2, here CH2, OH, here NH2. NH2. Functional group adjacent carbon is alpha and then beta, this one is gamma. On heating it eliminates as H2O. This OH group and this hydrogen is H2O is eliminated and the bond in between C double bond O and NH. Here C double bond O group, NH, CH2, CH2 and CH2. This is called gamma lactam. This is known as gamma lactam. C double bond of CH. Cyclic products will be formed. Note down this. Topic 10 minutes అయితే అయిపోతుంది. క్వశ్చన్స్ చేయాలా Next one. Protein synthesis. Next one, protein synthesis. In this protein synthesis, here NH2, here CHR and C double bond oxygen OH. This is amino acid of different. And another one is again NH2, CHR, C double bond oxygen OH, another amino acid NH2, CHR, C double bond oxygen. It's like this, you can write n number of amino acids. On heating, this OH group and this hydrogen is eliminated water molecule, and this OH and hydrogen is also eliminated. Like this it will be eliminated. And here also this hydrogen is eliminated and the chain will be continuous. Now the structure is NH, CHR, C double bond oxygen NH, CHR, C double bond oxygen NH, CHR, C double bond oxygen, chain will be continuous. We are observing here the C double bond O NH. The C double bond O NH group is peptide bond. Here the C double bond O NH group is peptide bond, it will be takes place. And this part is what about the peptide bond part. In amino acids, on heating, n number of water molecules are eliminated. By elimination of n number of water molecule, it will form as a protein structure. in this protein structure will having the peptide bonds, it will be there. So, the protein structures will having the 4 types of structures are there: alpha protein structure, beta protein structure, and alpha beta sheeted structure, that is also called primary proteins, secondary proteins, tertiary proteins, and quaternary proteins, it will be there. In the amino acid, what type of bonds it will be present means peptide bonds are there. Those peptide bonds will having the what type of units means C double bond NH units are there. Those proteins will having the 2 types, that is fibrous proteins and globular proteins. The polypeptide chains runs parallelly held together. These are the insoluble in water, that is fibrous proteins. In case of globular proteins means those proteins polypeptide chain coil around the structure is called as globular proteins. So, you can take the protein chain will having the like this helix structure, it will be there. In this helix structure, every turn will having the C double bond or NH group is there, and one turn C double bond group, another turn NH, that is hydrogen bond, it will be takes place. Like this, what about the primary protein will having the cyclic structure, or in case of coiled like structure is present. This is the protein chain. This protein chain will having like this coil structure, it will be there. In this coil structure, every structure will having C double bond group and NH groups are present. Like this, one turn C double bond NH group, another turn NH group and C double bond O, here it will be form hydrogen bonds. Due to this hydrogen bonds, that protein chain will having the more stable structure, it will be takes place. So, that is what about the primary protein structure. If you are taking secondary protein structure, the protein structure will having the 2 types of ends are present. One is NH end, another one is C double bond O end. One is NH end, another one is C double. For example, this is one protein structure. In this protein structure, one end is NH end and this end is C double bond. And if you are reverse, this structure will be like this. That reverse structure is having here C double bond end is present, here NH end is there. So, in this is one protein chain, this one is another protein chain. Here it will be bonding will be takes place. Here it will be bonding. In the middle also it will be bondings are takes place. So, this structure is called beta pleated structure. Beta pleated structure means why we can say that this is anti-parallel structure or parallel structure, it will be there. That is beta pleated structure, it will be takes place, that is anti-parallel. Anti-parallel means one end is NH end, another end is C double bond, it will be there. Another one is same side, if this when this NH side NH and C double bond or side C double bond is there, that is called as parallel structure, it will be there. So, alpha structure and beta structure, it will be there. And the proteins will having the polypeptide chains are there. In the polypeptide chains, what type of hydrogen bonds are present means intramolecular hydrogen bonds are there. Due to the intramolecular hydrogen bond, those compounds are more stabilized structure, it will be takes place. And the structure of proteins in your textbooks, it will be very clear, it will be there. That is primary protein structure, tertiary protein structure, and what about the quaternary protein. Primary protein structure is what about the straight chain, it will be takes place, that will be having secondary protein structure will having the alpha pleated or beta pleated. Tertiary protein will having the what over the clumsy nature or complex nature, it will be there, and quaternary will having the small units together, it will be binded. So, that is quaternary structure. All proteins will having the different type of biological functions, it will be takes place, and that proteins will having that more essential to the human body to develop the different type of muscle developments and food properties, that is proteins are utilized. Another one is denaturation of proteins. The denaturation of protein means the biological activity of protein when subjected to the pH and each and everything will be changes, that is denaturation, it will be there. Denaturation means that is what about the removal of the components, that is denaturation, it will be takes place. The best example is the coagulation of egg white on boiling in is irreversible, that is denaturation. Carried out without any affecting the primary structure of food. Denaturation means without affecting any structure, that is primary structure, means boiling of egg is also one of the best example, and curding of milk is also the examples of protein structures. And these are the what about the protein structure. And another one is for calculation of what about the isoelectric point, one principle is there for calculation purpose. That isoelectric point means acidic material and basic materials are there, amine group and acid nature. Based on that thing, that will be having pKa value, isoelectric point on what pH the materials will be having. Isoelectric point calculation, note down the principle. pKi, I means isoelectric point, pKa1 plus pKa2 by 2 means isoelectric point of pK value pKa1 plus pKa2 means that is acidic strength of the materials, two materials we have to calculate that principle. Based on that thing we are getting different type of compounds. A1 means one amino acids, A2 means another amino acid. In these two amino acids, that is we have to calculate the pKa value. Ka is directly proportional to SDT, pKa is inversely proportional to SDT, it will be takes place. Ka is directly proportional, pKa is inversely proportional, it will be takes place. Based on that thing, that Ka value is increases, pKa value is decreases. Carefully observe, Ka is directly proportional, A means acidic constant and B means basic constant. For calculating the isoelectric point of different type of amino acid, if they are given as two amino acids, that is pKa1 plus pKa2. pKa1 means that is 1 means that belongs to acid group, 2 means belongs to amine group. When these two are combining with each other, we are getting the compound. For example, if you are taking the example is alanine, if you are taking the example is alanine, that alanine will having that CH2, NH2, C double bond OH, it will be there. For the C double bond OH and NH2, one is A1, another one is A2. Like this, if you are representing amino acid, representing for C double bond OH pKa value is 2.34, the C double bond OH pKa value is 2.34 is there, and whereas NH2 the pKa value is 9.69 is there, and NH2 the pKa value is 9.69, it will be present. What is the isoelectric point of this alanine material? What is the isoelectric point of this alanine material means, what we have to do means that simplifies the principle is, in the examination if you are giving like this, they are giving the different type of amino acids. In that amino acid strength and basic strength, it will be given that. Based on that thing, to calculate the isoelectric point of that particular material, pKi is equal to 2.34 plus 9.69, 2.34 plus 9.69 by 2, 2.34 plus 9.69 by 2. We are getting what about the answer? That answer is what we are getting here, pKi is equal to 6.02. pKi is equal to 6.02. Like this we are calculating different amino acids, those what about the isoelectric points regarding the system. So isoelectric points are calculation this method by using the phenomenon. Now we are getting different type of isoelectric points of different type of compounds are there, that will be discussed in this connection of the examples. In your material will having different examples are there. In the material will having different examples are present. In those examples you can carry forward of the things. One question is there in your material, that will having that question is, One question is there here, number of peptide linkation in tripeptide. Number of peptide linkages in tripeptide. Here in the tripeptide, how many number of peptide linkages are present? The number of peptide linkages in tripeptide is 3, 2 means the answer will be, it will be 2, it will be there. Why 2 means tripeptide, tri means 3 amino acids here, NH2, CHR, C double bond OH, again NH2, CHR, C double bond OH, again NH2, CHR, C double bond OH. Here one water molecule. Tri means how many amino acids we have to see that tri. Tri means how many amino acids we have to take? 1, 2, 3 amino acids. In these 3 amino acids, removal of the water molecules. Here NH, NH2, CHR, C double bond oxygen NH, again CHR, C double bond oxygen NH, CHR, C double bond oxygen OH. Now, if you observe here, this is one peptide bond, this is another peptide bond. How many peptide bonds are there here? 2 peptide bonds are there. So, in the tripeptide, how many peptide units are present? 2 peptide units are. Tri means 3. If you are combining the 3 amino acids, number of peptide links in a tripeptide. Number of peptide links, how many peptide links are there? 2 peptide links. So, if like this they are asking the question, tripeptide means 3, 3 we have to decrease 1 means 2. If we are having the question is 4 peptides are there, how many peptide links are means 4 have to decrease 1, that is 3 units. Now, the question is tripeptide, how many peptide links are present? In the tripeptide is 3 amino acids are combined, we are getting 2. So, 3 minus 1 means that is number of amino acids minus 1, we are getting the peptide links. Number of amino acids minus 1, we are getting the peptide. Here how many amino acids are there? 3. 3 minus 1, 2 peptide. If 4 amino acids are there, we are getting 3. If 5 amino acids are there, we are getting 4. Like that. How we identify? That is n minus 1. Another one is which of the following alpha amino acid does not contain chiral carbon? Does not contain chiral carbon means the all, one question is there, does not contain chiral carbon. Chiral carbon, or we can say asymmetric carbon. Chiral center or asymmetric center, these two are same whatever the names. Chiral means asymmetric carbon is called chiral or asymmetric nature. So, all amino acids are optically active. All amino acids are optically active except glycine. So, glycine that will having the C double bond OH, C, NH2, and here also hydrogen is present, here also hydrogen. In the options, if they are given any number of any amino acids, whatever it may be, in the options if they give any number of amino acids, whatever it may be, that carbon 4 valencies are 4 different, then only it will be optically active. But whereas glycine, these 2 hydrogens are, this is the carbon atom, this carbon atom, these 2 hydrogens are same, but these 2 groups are different. But here the same atoms are there, automatically it is symmetrical. When it will be symmetrical, the compound is optically inactive, optically inactive. If it will having any one alkyl group is there, for example, COOH, carbon, here NH2 group, and here hydrogen group is present, if here alkyl group is there. So, then what happens, see that carbon, this carbon will surrounding, all are different groups. What are the different group? One is hydrogen is there, another one COOH, another one NH2 and alkyl group. All groups are different. When all groups are different, this carbon is called chiral carbon and this is also called asymmetric carbon. So, this type of compounds are shows whatever the optical activity. So, optical and the entire amino acid structure except glycine. Remaining all amino acids are optically active. Remaining all amino acids are optically active. A sulfur containing amino acids are there. Sulfur containing amino acids are, what about this here? The sulfur containing means two types of compounds are there, sulfur containing amino acids. In that sulfur containing amino acids are cysteine and dicysteine, we are discussing the earlier. In that alanine will have in the CH3, CH, NH2, COH group present. In the CH3 position, one hydrogen is removed and mercaptone group. Mercaptone means SH group is added, that is cysteine. And if two cysteine units are combined together, it will form dicysteine. So, the sulfur containing amino acids are, what about this? Cysteine compound is sulfur containing amino acid. So, like this, you have to different questions in that amino acid. Carefully observe in that amino acids the chain, and in your material the amino acid chart is there. In that amino acids are, see that what are the differences or classifications and each and everything, and see the reactions and write the reactions accordingly, and go for biomolecules in the carbohydrates and amino acids. The back side will have the different questions are there in to practice it. Because of this biomolecule having the huge structure, it will be there. So, due to that reason, they are asking in that name, based on the name wise they are asking the questions. So, that is the reason, if you are having whatever the proper knowledge on the structure, we can easily do the different type of answers. And this part is belongs to amino acids, and carefully read the textbook. In the textbook we will have in the whatever that structures are there in the clear-mized primary protein structure, secondary protein structure, tertiary and quaternary structure, and those structures, based on the structure how the functions it will be there, that is clear in your textbook. And carefully read and practice that material in your material. The modules, module 1, 2, 3, 4 is there. In that all the modules, if you practice it, it's more beneficial to that. And these are the topic belongs to amino acids.